or alpha factor analysis. And this is it's testing, basically testing in the same way that Bartlett's test of sphericity does against the original observed correlation matrix. It's testing the residual correlation matrix for at least one statistically significant correlation. And I know that there's going to be at least one more, there's going to be at least a residual correlation matrix. So it's telling us from a statistical significance perspective that there's still more shared variance that could be accounted for by extracting more factors. But I don't want to do that because I know that those extra quote-unquote factors are so weak that they're not real factors. So it's not really useful to use the goodness of fit test because it's much too sensitive to sample size, and it's too sensitive to to specificity, something like a specific residual between two items. But it will come in use in partial confirmatory factor analysis, as I'll demonstrate in another video in the future. Here's the reproduced correlation matrix. I'm not going to say a lot of that, but you can uncover the reproduced correlation matrix by multiplying the factor loadings that are actually associated in the factor solution. But basically, the closer that the reproduced correlation matrix is to the observed correlation matrix. So if we look at the correlation between DIF item 1 and item 2 in the reproduced correlation matrix is 0.48, in the actual observed correlation matrix it was estimated at 0.538. So in a conceptual sense, we could say that the difference between 0.538 and 0.483 is in fact what we're going to get as the residual correlation matrix. That's what's left. So the factor analysis produced, based on the factor loadings, the equivalent of a correlation of 0.48, which is smaller than the observed correlation, equal to 0.055. So what you're hoping to do in a factor analysis is account for all of the correlations in the observed correlation matrix. And the better you can do that, the better your factor solution may be said to be, or the better the number of factors you've extracted is appropriate. But we can see that there's still some, well, in fact, I would say 0.05 is one of the biggest residual correlation matrix these are the correlations that weren't accounted for by the factor analysis, but there's not a lot. I mean, here's one that's negative 0.13. It's pretty close to 0, and what you can do is actually take these coefficients and then plot them in a histogram, which I do in the partial confirmatory factor analysis. Anyway, sometimes what you'll find is 1 or 2 or 3 really big residual correlations, and you'll say, oh wow, so these variables might themselves form another factor, or it might tell you that there's something really there's something that those two variables share in common that the factor analysis based on the factors extracted hasn't included in the model solution. Here's the pattern matrix. In my opinion, the pattern matrix, when you rotate, particularly obliquely, is the most important factor solution to interpret. It's, in my opinion, it's always the most intelligible. And here we've gotten the first factor, the difficulty identifying feelings factor. Because I've sorted the factor loadings by size, we get a nice big series of factor loadings. So the item 9, 13, 7, 14, these are all DIF factors or subscale items. And then it stops precipitously, because now I'm entering into the externally oriented thinking factor, which is the second factor. And here we've got the items here going from larger to smaller. So that formed a nice factor there. And then finally, we've got the DDF, difficulty describing feelings, and the factor loadings for that subscale or factor are in the third or subscale are in the third factor. Now the fact that these are negative is not significant or not meaningful. You could reflect all these factor loadings into positive ones and then make the positive ones negative, and that is perfectly fine in factor analysis. It's arbitrary how it determines whether it's going to be positive or negative. So long as all the ones that are negative are changed into positives and all the ones that are positives are then changed to negatives, that's fine to report that and interpret a factor solution that way. But overall, we can say that there's some overall general consistency with the three-factor model solution that was published in other research.